All right, so test out covered the OSI model and the various concepts around that. They also covered encapsulation, packet encapsulation, and then they also covered the TCP IP protocols and some of the ports and so forth. And a lot of that can make your head swim if you haven't run across any of that before and you really don't know what that looks like. So let me quickly go over those points again. So the OSI model, you might think, well, why do I need to know all of this stuff? It's like really kind of mind-boggling, really frustrating. Why do I have to remember these weird acronyms or whatever to help you remember all of the layers of the OSI model? And what is the point of that? And why did they create layers? So the OSI model is a theoretical view of what network devices, how they communicate on the network. And so you have your layer 1, which is basically your hardwire connection, it plugs in. You have your layer 2, which is your data layer. And that would be, just the basic flow of information. There's like no control or anything like that. Layer 3, there's a little bit more control. Layer 4, more control. And then, you just work your way up to, a session layer, how it connects and, creates the link between the two nodes, etc. And so really those layers of the OSI model really show you the different devices and the different software and kind of where they fall in and how they provide a way for devices to interact with each other on the network. So one of the things you'll run into as a network admin are layer 2, layer 3, and layer 4 devices. So layer 2 device, again layer 1 device is just plugging a hardwire in. Layer 2 device would be something like a hub. And a hub provides multiple Ethernet connections when let's say there's only one drop in the room. There's only one Ethernet connection available and you have multiple devices that need to connect to the internet or to the network. One of the ways to do it is to install a hub. And a hub is a layer 2 device. Basically it just rebroadcasts the traffic. It allows multiple devices to connect to that one connection and then just rebroadcasts everything. So that would be comparable to, let's say you were in a big business. You were there to deliver a letter. You went into this big business, and it's really busy there, a lot of people, a lot of offices, and you really have no idea where you're going. You have this letter addressed to Mr. Smith. And so a hub, what it does is it then grabs a megaphone that says, hey, I'm looking for Mr. Smith. Has anybody seen Mr. Smith? Does anybody know where Mr. Smith is at? And that just continues to happen until finally Mr. Smith, who's hopefully been listening, says, yeah, I'm up here in this office. So that would be a hub. So the problem with that, it's a fairly easy way to connect, provide extra connections to devices and so forth. The issue with that is, as you can imagine, if you walked into a busy business and pulled out a megaphone, and started to broadcast your voice to everybody listening, you would be a massive interruption. And in data terms, you would cause collisions. So collisions on a hub are quite common. So when multiple devices are talking at one time, eventually there's going to be collisions of data. Only a few people can talk at the same time and actually hear each other. But again, a hub is kind of an inexpensive way to provide multiple connections to a single connection room, let's say. Then you go up to layer 3. And layer 3 is where you have more of your edge switches. Now these switches, they don't route, but they kind of know how to process traffic. They know how to encapsulate it and send it where it needs to go. They create collision domains, which means that somebody isn't standing in the lobby with a megaphone anymore. They are actually able to be sent to where they need to go. So go back to the instance where you're the letter carrier. You have a letter to Mr. Smith, you walk in, you go to the directory, it kind of tells you where to go from that point, and then you just kind of find your way along as you walk down the offices. And so, you're looking for office 218B, and you figure out it's on the second floor, and you just kind of wander your way around until you find 218B and go, okay, I've got a letter for Mr. Smith, and he goes, yes, I'm Mr. Smith, and okay, there you go. And that letter has been delivered. So that's kind of a layer 3 device. That's a switch. Again, it creates a collision domain, which means that you're not going to really have any collisions anymore because you don't have somebody down there with yelling their lungs out trying to find somebody. And it's kind of the same way on a network. Then you have a layer 4 device, which a router and some core switches work at. So a router knows how to route traffic. So go back to the instance where you're delivering a letter to Mr. Smith. You walk into the lobby. Not only are you directed where to go, you are actually taken to Mr. Smith's office. You walk up, you get identification confirmation that yes, this is Mr. Smith, and you hand him the envelope. And so that's the difference between layer 2, layer 3, and layer 4 devices. Again, as a network admin, you're going to need to know those things, so that way when you go to install a device, you're going to know what it can and can't do, what services it can and can't provide. And you definitely don't want to be installing like routers everywhere, because if you did that, I mean, it's not bad, but you're going to have unnecessary equipment laying around that's A, really expensive, B, that's doing a lot of extra routing when it may not need to. So in the case of, unless it's a huge business, or you're going from one LAN to another, let's say 2 separate sections of the city or whatever, you're not going to really need routers all over the place. What you need is maybe one router and one core switch, and or core switch, also called a distribution switch, and then a bunch of edge switches. They're cheaper and they get the job done. They provide all of those connections. They allow, they're managed, so they allow that routing to take place without actually routing. The router handles all of that in the background. It just tells the switch what to do and where to send the traffic. So again, those are the differences between some of the OSI layers that you're going to run across as a network admin. Those are important things to remember. And then if you go up the OSI level, OSI layers, you're going to see how different software connects, how sessions are actually created. If you get into cybersecurity, you're going to need to know some of that stuff as well. So the OSI model, also there's a TCP model out there. It simplifies things a little bit more, but the OSI model is still kind of used in most of the IT business. So you will need to know that. It's also part of the Network Plus exam, so you'll need to know the layers, kind of what they do. But again, as a network admin, you're going to need to be familiar with some of those layers. As a cybersecurity person, you're going to need to be familiar with more layers. So the OSI model is important. It's not just a bunch of random stuff that they try to throw at you. Try to think of it, again, it's not logical in the sense that, okay, it starts here and it works its way up necessarily. Or it starts here and works its way down. It can do that, but the OSI model, again, is just like containers. It's like a shelf with a bunch of containers, and you say, okay, what network device or what software fits in this particular container? And you find the container that it fits in. And so that's kind of how the OSI model is. It gives containers for certain functions of those network devices. So all of that to say, when it comes down to data packetting, so packets and frames and so forth, you go, gosh, what is all of that? And then you have tags, and you have the various things that go inside a packet, a frame. And to simplify it, to kind of help you understand it a little bit easier, think of a box. We're going to take this box right here. So we have data that needs to be sent out. We can't just send raw data out. That doesn't work. The receiving device, well, for one thing, the network transmission node won't know what to do with it. If it just gets raw information, it's like if you need to send a letter or a package to somebody, such as this box, we wouldn't just say, we wouldn't go to the post office, to FedEx or wherever, and say, I need to ship this to somebody over in New York. And they're going to look at you and go, okay, so you want to put it in a box? Well, no, I just want to send it like this. Well, for one thing, it has no label on it. They're not going to have any idea where it goes. And, it's going to get damaged. There are people who are going to be able to see what it is. It's like, no, you need to really put that inside a box, put a proper label on it. Of course, then there are taxes and so forth that you have to pay. But in the networking world, it kind of works the same way. You need to send some data to somebody. So what you do is you got to get yourself a box. Put that thing in there with proper packaging. You're going to seal up the box. You're going to put your labels on it, who it's coming from, where it's going to, the weight, and any other information that's needed in order to send this box through the mail to its destination. And so too, data packets are the same way. they're packaged up so that way when they go from your device, okay, so back up just a little bit. If you're going to send a document to somebody, the way data works is it goes through the wires as power, basically. It's going through as binary, zeros and ones. And it does so in pieces. So if you've got a 2 megabyte file, it's not going to send all 2 megabytes at the same time. It's going to get broken up into certain sizes. You'll have multiple, basically, boxes going out with who it's from, who it's to, the sequence of the box, depending on the TCP transmission, if it's TCP or UDP. So the size, just all sorts of information regarding that packet. And the receiving device needs to know what it's receiving. So your computer is going to send a document to another computer, let's say over the network. We'll just use a very basic example. You're going to send your document to a data server. Your computer is connected to a switch, and which is connected to another switch, which then the data server is connected to. So it's fairly simple, but the network node that's doing the routing needs to know where to send that package. Basically, it's like when you take it to the post office. They need to know where to send it. So it's sending it to the various locations as it's going out. So the switch receives it and says, okay, I have a package from so-and-so. It's going to the data server, and I need to send it on to these destinations in order to make it to the data server. So it has one more hop to go before it gets to the data server. So it goes, okay, I'm going to package it up. I'm going to also add another label to it that says, this is where it's from, and this is the route it needs to take. It then sends it out. Again, the switch is not making that decision. It's getting that information from the router. It just knows a pathway in which to send all of that information, but it has to put more labels on that box in order for it to go out properly. So the box goes out to the next switch. The switch receives it and says, okay, I know who this box is for. It then unpacks it a little bit and says, okay, I need to send it on to this destination. Then the receiver gets it and completely unpackages it. But then also notes that this is box 1 of 50. And so it's going to go, okay, I got box 1. So now that it's received box 1, it then sends an acknowledgement that says, I've received box 1, I'm waiting for box 2. And your device then sends on box 2. And it waits for the device to get box 2 and says, okay, I've got box 2. Your device sends box 3, box 4, etc., etc. Somewhere along the line, because it uses TCP, if you're transferring a file, it's going to be using TCP, which means that the receiving computer checks to make sure it's getting those boxes in its proper order, or at least it's getting the boxes that it needs. And so let's say the data server goes, okay, I received box 4, I'm waiting for box 5, and all of a sudden box 6 shows up. It goes, whoa, wait a minute, I got box 6. I was waiting for box 5. Your device goes, ooh, okay, let's start that over again, and then it resends the transmission until it gets the proper order of boxes. That's TCP. We're transitioning now into the TCP/IP protocols and some of the ports and so forth that they're going to use. And so TCP, again, make sure that your device or that the data is received in the proper order that it was sent, because it needs to rebuild all of that information perfectly, accurately. So if you're sending a document to the data server, you want to make sure that your document, when you save it to the data server, is actually the same as the one on your computer. Because if the data server didn't care if it wasn't using TCP, and it received box 6 and box 8 and box 13 and box 20 and box 2 and box 5, it's going to just kind of start shoving it all together, and when you go to look at your document, it's going to be completely corrupted. So that's why TCP is used. We're going to jump over real quick to UDP, which is another IP protocol. And you'll learn more about this later, but UDP is used for quick transmission, so video, audio, voice, etc. That it doesn't matter if the receiving node gets all of the boxes in their order. So when you've ever been connected, let's say you're streaming on YouTube and you're watching something and all of a sudden you see it kind of go pixelated and get kind of weird for a second. It's because packets have been dropped. So you, as the receiver, have received, packet 384, 385, 390, 392, 395. You can kind of see how it's dropping packets along the way, which is okay because if it was TCP, the computer would spend so much time confirming, acknowledging, confirming, making sure that all of the data was correct, that your video would be incredibly slow. So, because it's having to process pixels at a time, not necessarily frames, it would be incredibly slow at building all of that. So UDP is used for quick transmission. It doesn't really matter if a few packets are dropped, because even if a few pixels are missing or your voice kind of for just a brief second, it doesn't really matter because the overall message has been received. And your brain can make up the difference. Or, let's say it's a voice call and somebody's talking and all of a sudden they, they start doing that weird robotic noise, and you hear that and it, their transmission is suddenly interrupted, and then all of a sudden they come back on again. You can go, okay, would you mind repeating that last part you kind of cut out? We're used to doing that. And so then they repeat themselves and all is good. UDP doesn't really care if you receive all the packets or not, and you shouldn't care because, again, you're looking for speed, not quality. Back to TCP again. The TCP uses the proper protocols to make sure data is transferred properly, received properly, that security is proper. The TCP protocols are really important for data transmission, for sensitive data transmission especially, for security, etc. So, and then you come to ports. Ports are where the device listens for certain types of traffic. Port is just kind of a general term that's used. It's not obviously not really a port. There aren't really outlets that are plugged in. It's just a virtual way, a theoretical way for a device to listen for specific types of traffic. And there are thousands of ports. And as a network admin, you're going to need to be aware of that. As a cybersecurity person, you're going to need to be made aware of that, because hackers can use open ports to gain access to a system. So a system is listening for specific types of traffic. If a hacker is going to be using that port and says, okay, I'm going to issue a command that I know the server is listening for. If that port is open, the server's got its ear basically to the port, and I'm going to issue that command that I know the server will then respond to. The server hears the command, responds, yes, I'm here, and then the hacker goes, good, that port is open. I can now start issuing other commands, and that server will be listening. Once I gain access, I gain entry into the server, I can then spread around and search the network. So ports need to be shut down if they're not in use. And really, you need to shut down, and most servers these days, all server operating systems past, I think it's 2016, automatically shut all ports. They block all ports, so you have to go in and say, okay, I'm going to open these ports up because I will definitely be getting traffic on these ports, port 80, port whatever, port 25 if you're going to be doing that. So knowing what ports, what services they go to is definitely important. So they gave you a list of TCP ports. You'll be asked about that on the test if you take the test, but you should also be aware of it as a network admin or as a cybersecurity person, because you will need, again, to be aware of those ports and the services that those ports use. Also, because if you're going to use that particular service, you need to make sure that the port is open, that certain types of traffic are allowed through that port, not just necessarily any traffic, but certain types of traffic, that it's restricted to maybe certain devices or certain programs, etc. And this is where the firewall comes in, which we will talk about much later in the semester. But this is just kind of a preview to get you going and to give you a basic understanding of data transfer over the network, the different devices, different layers, different containers, again, that the nodes, software, etc. go into, how they process that information, how it's packaged up, how it's sent to the receiver, how it's received and processed through the various ports and the protocols, etc. So that was this chapter in review. If you have any questions, please let me know, and I would be happy to go over any of this in more detail with you.